At the age of 17, this young man managed to build an electric motor that could revolutionize the automotive industry. His interest in electric cars began when he watched a video at age 15 about the downsides of expensive and environmentally damaging components in electric motors. With this idea in mind, he decided to create his own electric motor that did not rely on rare earth metals. After researching and experimenting, he found the solution in adapting a synchronous reluctance motor. Despite not having access to advanced resources, he managed to create a working prototype using a 3D printer and his ingenuity. This achievement is not a surprise considering that the youngster had already completed more than 60 engineering projects, including robotic hands, a go-kart, and high-speed running boots. His passion and dedication make him an engineering prodigy. Robert Samsung's electric motor started out as just another project, but recognizing the potential in it, he decided to turn it into a science fair project. His enthusiasm led him to compete at different levels until he reached the Regeneron International Science and Engineering Fair, where he won the first prize of $75,000. With the money, Samsung plans to enroll at the Massachusetts Institute of Technology to further refine his model. Although he hasn't revealed all the details about how it works, he hopes car companies will take an interest in its electric drive to make a sustainable difference in the creation of electric cars. However, the automotive industry is changing towards a 100% electric future, which brings with it the problem of the use of components such as rare earths in motors and batteries, elements that produce environmental and social impacts. Currently, more than 90% of rare earths are mined from China, which poses a challenge for the replacement of all existing vehicles with an electric one. A University of Michigan professor explained that many of the materials used in engines are mined in China, which makes their price tied to trade status with that country. Rare earths, from which 17 chemical elements such as scandium, yttrium, and lambane are extracted, are essential for generating clean energy, but they are also highly polluting. Although they are found in nature, their low concentration makes their commercial exploitation difficult. Rare earth metals, such as neodymium, dysprosium, and terbium, are used in the construction of electric motors and electronic devices, as they are used as magnets to prevent overheating and improve performance. In addition, the military sector also depends on these elements. U.S. President Joe Biden has a goal for 50% of cars sold by 2030 to be electric, but current demand for rare earths makes this difficult to meet. Furthermore, countries like Germany, Japan, and Korea also require large amounts of these elements for their electrification goals. Due to shortages in the United States, the possibility of collaborating with Australia and Canada to obtain and process rare earths in the state of Texas is being explored. Although we face challenges such as high production demand, high costs, and environmental pollution associated with the use of rare earths in electric motors, removing these elements from the equation could solve many of these problems. For this reason, Robertson developed an alternative with his synchronous reluctance motor that does not require rare earths. Magnets are an essential component in everyday life, used in numerous electronic devices and turbines. And growing demand from the automotive and clean energy industry has increased the need for rare earth metals. Although neodymium magnets are the most powerful, their scarcity has led to a search for substitutes, such as cerium. However, more studies are needed to determine its potential. Permanent magnets have become popular in the automotive industry due to their performance and strength, and Tesla has recently started using them in their motors. For an electrical act to occur, permanent magnets are required to maintain their magnetization for long periods. In an electric motor, electrical energy is converted into mechanical energy through a coil that, when passing through a magnetic field, generates a force that produces a rotational movement torque and, therefore, a mechanical force that is transferred to the wheels of the car to achieve its movement. The center of the electric motor is its armature, a metal loop that when connected to a current becomes a large flat magnet with a north pole and a south pole that can be switched by reversing the polarity. In a DC motor, curved north and south pole magnets form a stator, while the armature rotates to align with the stator's magnetic poles, producing mechanical energy when the polarity is reversed. Alternating current motors, for their part, use energy sent to the stator coils to produce a magnetic field in the rotor, which moves trying to reach this rotating field. These motors do not need permanent magnets and were popularized by the inventor Nikola Tesla, being used by 70% of companies today for various purposes. Consequently, Samsung created a prototype motor that does not rely on rare earth metals by using a synchronous reluctance motor instead of one with permanent magnets. This type of motor uses a steel rotor with slots cut, which increase the difference between the low magnetic reluctance of the rotor and the high magnetic reluctance of the slots, increasing the motor's prominence ratio and therefore power. Although automakers don't use this type of motor because they don't consider it as efficient for electric cars, Samsung has shown that it's possible to make a synchronous reluctance motor as efficient as one with permanent magnets by removing the air gaps and adding another magnetic field. Samsung's prototype showed that this type of engine can produce 39% more torque and be 31% more efficient at 300 RPM. Furthermore, if this type of motor were to be implemented in the automotive industry, electric cars would not need permanent magnets and therefore would not be dependent on China's rare earth monopoly. This would reduce the environmental impact and the price of electric cars, making them more accessible to consumers. Robert Sands' success in his high school science project bodes well for his future. He is expected to be a promising candidate for the Massachusetts Institute of Technology as an engineer, although the synchronous reductance motor of it still needs to undergo several phases of testing to demonstrate its true potential. The current results are promising. As we live in a time of energy transition, it is important to reflect on the best options for our future, as some clean energy projects may have underlying environmental issues. So it's crucial that brilliant minds like Robert's get the support they need. Do you think Samsung's engine could be used in the automotive industry? Leave us your comments. If this video has been useful to you, please share it with us in the comment section and give it a like. You can also send the link to your friends and family so they can learn more about the technological advances of the future. If you are new to our channel, don't forget to subscribe to the channel, like it, and activate the bell so you don't miss out on more content like this.